This video is about metric prefixes and metric units. It corresponds to section 2.1 of the Applied Analog Electronics textbook. The basic problem that we have to address is how are we going to write our measurements. And there's a fairly simple standard form that we have. We're going to have a number. Then we're going to have a prefix and units. As an example, we might have 10 microfarads. The number is always going to be between 1 and 1,000. The prefix is going to be used to adjust the number to be in that range, and the units are going to be one of the standard metric units. Okay, why do we have this range between 1 and 1,000? Mainly, it's to avoid having a lot of zeros. Because if you have a number like 10 microfarads, I could write that as 0.0000, let's see if I get the right number, 0.001 farads. And it is very hard to read this number and get the number of zeros right. It's very easy to slip and be off by a factor of 10 or even 100. And that could be a really serious error. So to avoid that, we want to never have this bunch of leading zeros. And that's where this always have a number bigger than 1. Don't have a leading zero. There's another problem with the leading zeros is that sometimes people will write numbers like 0.5 seconds. And that little decimal point there is really easy to lose. And so this may very easily get transcribed sometime as 5 seconds. And it's really, really different whether you've got 5 seconds or 0.5 seconds. Little glitches with the pen. Is that a point or isn't it? Who can tell? So if you do ever have to write a number less than 1, always put a leading zero. Because 0.5 is unambiguous. If the decimal point disappears because of dirt or noise or whatever, we still have the 0 in front there that warns us that something's wrong. We've got a leading 0, and we don't do leading zeros unless there's a decimal point. So always, if you've got a decimal point, don't start with it. We do not allow starting numbers with a decimal point. You can only start a number with a digit or a minus sign followed by a digit. Okay, so that tells us why greater or equal to 1. It's because we don't want to have leading zeros. Why less than 1,000? Well, it's the same problem. We might have a number like, what's a good number? 2200000 ohms. And it's really easy to drop one of those zeros and be off by a factor of 10. So we would never write that. We would write this as 2.2 mega ohms. And the reason for 1,000 is that the prefixes that we use allow us to easily do powers of 1,000. So we can always scale whatever our number starts out being to being in this range just by using prefixes that are powers of 1,000. Let's take a look at those prefixes. Okay, here's a table of all the standard metric prefixes. We don't use all of them in this course because we don't need this big a range. I mean, physicists like to have really huge numbers and really tiny numbers. We don't need those. For the most part, we'll be dealing with ones from up to maybe tera and down to maybe pico, so sort of this range. And sometimes we might use femto. But basically, the middle of this range is what we use. We never use hecto. we never use deca. Just forget that they even exist. You'll never need them. There's two that you'll see but very, very rarely, and that's deci and centi. Basically, deci is only used in decibels, and you can just think of that as a single word and forget the fact that it's got a prefix. And centi pretty much only gets used in centimeter, and that's only because it's a common usage in normal English. And you don't ever really need to use centimeter. You have to understand if somebody else uses it. You can always just use millimeter and not have to worry about anything other than these 10 to the 12th, 10 to the 9th, 10 to the 6th, 10 to the 3rd, 10 to the minus 3rd, 10 to the minus 6th, 10 to the minus 9th, 10 to the minus 12th. Those are all powers of 1,000. And so if we want to express a really large number, we express it in terms of mega or giga or tera, whatever the unit is. If we want to specify a really small number, milli or micro or nano or pico. And that lets us always keep our number between 1 and 1,000. And that's a really convenient thing to do. One problem: these are prefixes. They have to be attached to something else. They're not standalone words. Notice I've got a hyphen here at the end of each one. That hyphen is a reminder that this is a prefix and it actually attaches to something else. Though usually the hyphen disappears when the prefix gets attached. So we can have microamps or microvolts, but we can't just have micros. It's not a noun, it's a prefix. Well, what do we do if we've got a number, though, that doesn't have a unit, that is just a raw number, a ratio or something like that, and we say, oh, it's 10 million. How do we write that if we don't want to have lots of zeros? Well, there is a trick we use for doing that, and that is to use something that computer scientists sometimes refer to as floating point notation. Though it's decimal floating point notation, and computer scientists usually mean binary floating point. And what that consists of is a number. Well, let's write out this 2.2 million if we didn't have ohms. We could write that as 2.2 E6. And if we want to still say ohms, we could put ohms here. And this capital E corresponds to 10 to the power. So this is the same thing as writing 2.2 times 10 to the 6th power. It's a better way to write it than this because it's very easy for that space to get lost. And this thing is a single number. It doesn't imply any multiplication, any exponentiation. It's just the number 2.2 million. And the number here that comes after the E, so it's the exponent of the 10, should be always a multiple of 3. When it's a multiple of 3, it's sometimes referred to as engineering notation, as opposed to scientific notation, where they don't put that constraint on it. In scientific notation, you could have 2E7. That's not well-formed engineering notation. Engineering notation, we would use 20E6. And that's because this E6 and E3 and those all translate into the standard prefixes that we use. So I can read this thing as 2.2 mega ohms. Even though it says E6 here, I can immediately see that that's mega. Whereas if it's E7, I have to do some shifting of decimal points. And it's really easy to make a mistake when you're shifting decimal points around. So just as a standard practice, we only use multiples of 3, which is powers of 1,000, in this position. So engineering notation is available on a lot of calculators. If your calculator has the option of setting things in engineering notations, you might want to do that. Let's take a look at what some of these units are that we have to deal with. Okay, so here's the table from the book again. These are most of the units that we end up using in this course. And we have time, distance, volume, mass, temperature, frequency, force, pressure, things that we measure, and then the electrical things that our sensors convert things to. And it's important to learn these symbols and put them with the prefixes. So we can have milliseconds, which would be a little m followed by a little s. We could have meters, which is a little m. We start running into problems when we want to deal with things that involve meters, because meters look like milli. It's the same lowercase m. And so you have to be a little careful about making things clear. And sometimes people put dots, and when you've got multiple units multiplied together, sometimes people put a center dot between the units to indicate that there's a multiplication going on. I haven't been using that convention in this book. I've been putting spaces, as you can see in the column over here on the right, like the newtons being kilogram meter per second squared. The kilogram there's no space between the kilo and the gram, but there's a space between the gram and the meter. You have to be very careful about capitalization. There's the unit there that's pascals. Well, we've got both pascals, which is capital P little a, and in the very same design report, you may have to deal with picoamps, which is a lowercase p and a capital A. Those capitalization matters a lot with these things. Capital K is Kelvin, which is a temperature. Lowercase k is kilo, which is a prefix for a factor of 1,000. Don't mix them up. Some of the prefixes themselves, we go back to these, we have a capital M for mega and a lowercase m for milli. Mix those up and you're off by a factor of 10 to the 9th. It can even get worse than that, because we have capital Y and lowercase y. Perhaps I need to scroll this up a little bit so you can see. Capital Y and lowercase y would be a factor of 10 to the 48th different. Capital P and lowercase p, that's peta and pico, that's 10 to the 15th and 10 to the minus 12th. That's a factor of 10 to the 27th difference in ratio. So be very, very careful about your capitalization of your prefixes and also of your units, because we had two units that were just difference in capitalizations, seconds and Siemens. So things you need to be careful about. Okay, bottom line, write your numbers carefully, use either engineering notation or preferably units with prefixes. So numbers always between 1 and 1,000, prefix and units, or if you don't have units, then engineering style floating point notation. Never start with a period. If you have to do a number less than 1, start with a leading 0. And you do all that, pay attention to your capitalization, and you'll get a lot fewer errors in your designs.